if you're given this problem here, children, and maybe you'll understand this when we do this here, if you have, hold on a second, get a good one here. If you have 2.4 times 10 to the 6th, and you're multiplying that by 2 times 10 to the 5th. 2.0 times 10 to the 5th. Now, if you want to multiply those together, one way would be to change them to their regular numbers and then multiply them. What is the regular number for this? 2.4 times 10 to the 6th would be what number in standard form? Because usually when you go, the clerk at the store doesn't say your grocery bill is 1.68 times 10 to the 3rd power in dollars. It is what, Samantha? Well, how many places am I going to move the decimal over? Help me out here. What is this thing? 6. So I move the decimal over 6 places, it's going to be like this. Here's 1 place, 2 place, 3 place, 4 place, 5 place, 6 places. This number stands for 2,400,000. Okay? To that, I guess I'm going to multiply, what would this number be? A 2 with 5 zeros after it. So you've got this. Now, in order to multiply that out, how do we have to do that? Anybody? Suggestions? How am I going to do this, Peter? Peter says we learned a way back in math to hang the zeros out to the end, drop them all down, and then multiply, which I guess we could have done here, which means I would do this. 2, 4, 0, 0, 0, 0, and I'm losing, times 2 with what? 5 zeros after it? Which means I can drop those 5 zeros, right? 1, 2, 3, 4, 5, correct? Then I multiply by the 2, 0, 0, 0, 0, 0. 2 times 4 is 8, and 2 times 2 is 4, right? And then my answer is this. What is that, 480 billion? Is that correct? Okay. Now, that's all well and good, I suppose, if they're easy numbers like this, but what if the number was this, 1.63 times 10 to the 8th, and you were multiplying it by 3.5 times 10 to the 5th? Okay. Might be get a touch confusing there, may or may not? Anybody? Okay. So, we don't have to do this, children. Okay? That would be the very long, sort of obnoxious way to do this, because if you remember David talking about this yesterday, there's a very simple, like 2 or 3 step process to do here. And it just works like this. Step number 1 is you multiply, sorry, I don't know how that happened, is you multiply the left sides together. In other words, step number 1 says you multiply these 2 things together. And you could probably almost do that in your head, correct? What is 2.4 times 2? Anybody? 2.4 times 2 is 4.8, correct? So I have my 4.8. Step 2 is you write down the times 10 part, because you're going to actually write this in scientific notation. Times 10. And then step 3, and here's where things get a little dicey for people, is you need to multiply the right sides together. Now here's where you need to focus with me, your children. Okay? What do I get when I multiply 10 to the 6th times 10 to the 5th? Now people logically want to say it's 10 to the 30th power, but that's not what it is. This means you have 6 tens times themselves. That's what 10 to the 6th power is. And to that you're multiplying 5 tens times themselves. Which means, in essence, I am then multiplying what, Gary?
It's 10 to the 11th.
It is 10 to the 11th power. You need to remember, when you multiply this, that means you just add the exponents. And it is our hope that this and this are the same thing. This should be this in scientific notation, is it? 3, 6, 9, 10, 11. 4.8 times 10 to the 11th power. Now, you need to make sure, as step number 4, your answer needs to be in scientific notation as well. Okay, your answer needs to be in that same scientific notation. Okay, now that's going to come up here. You might ask why I say that. Okay, there's a few things. If you're not a good note taker and you don't like to look back at your notes, you're going to get these wrong. I'll tell you right now because you're too lazy to do that. Let me give you this problem. 4.0 times 10 to the 8th times 4.0 times 10 to the 9th. What do I get if I multiply the two left sides together? 4 times 4 is 16. I multiply the 10 to the 8th times 10 to the 9th, I get 10 to the 17th. Stop me if you didn't catch that, because we're not done yet, but I need to know that you are that far. Anybody not see where something comes from? 4 times 4 is 16. When you multiply numbers that have exponents together, you add their exponents. Okay, here is where we hit kind of a roadblock. This is not in scientific notation. Why? Anybody? There's a decimal still not in scientific notation. Wow. Awkward silence time. Somebody? If you went back to your rules of scientific notation, Ariel?
Speed parentheses.
No. Scientific notation does not have to be in parentheses. It does in that case because we're multiplying. Grace?
You move the decimal left, so there's no.
Okay. You are not allowed to have a number that is greater than 10 in scientific notation. This number always had to be a number between 1 and 9 or whatever. There can only be one digit to the left of the decimal. Okay? But there's an easy fix for that. Okay? Like Grace said, you just move the decimal one place left and you get 1.6. However, you just can't say that 16 is the same as 1.6 because it's not the same. So you have to adjust over here as well. Okay, and the rule is this. If you make this smaller, you have to balance it out by making this bigger. So if I move the decimal one place here and made it one smaller, I have to move and add 1 to the exponent 10 and this becomes 1 bigger. 16 times 10 to the 17th is the same as 1.6 times 10 to the 18th, but this is in scientific notation now. We'll do just a couple of those because I understand how that's going to be. Okay, so think about it as balancing it out. If you make this smaller, this has to become bigger. So how about this? What if I'm given 0.52 times 10 to the 9th power? And I ask you to make that in scientific notation. Okay, first of all, where does the decimal have to go over here to make it in scientific notation? Somebody, Ariel? I need a number between 1 and 10, so I need to move it how many places? Just once. So this becomes 5.2. Now, did I make this number smaller or bigger when I move that decimal? Bigger, so that means this exponent has to become smaller. And I moved it one place, so it becomes 1 smaller. So it becomes 5.2 times 10 to the 8th power. They balance themselves out. Let's look at a goofy one. What if I had this? .00035, or whatever it is, times 10 to the 10th power. Where, how many places do I have to move my decimal? To get it between the number and 1 and 10, Christian? 5 places. So I am going to do something with 5 over here. Okay, I move it 1, 2, 3, 4, 5, so it's 3.5. Now the question is, am I going to add 5 to 10 or subtract 5 to it? Right, I made this 5 bigger, this has to become 5 smaller. So this becomes 10 to the 5th power. Okay, or how about this? What about 7863.2 times 10 to the 3rd power? Write that in scientific notation for me. Who wants to take a shot at it? Emily?
7.8632 times 10
10
to the 7th power.
to the who power? 2nd power? Well, here's a question. How many places did you have to move the decimal in? I think 1, 2, 3. So you're going to do something with 3 to that. You're either going to add 3 or subtract 3 to that. Okay? I made this 3 smaller. It went from this number, 7,000, down to 7, so it went 3 smaller. So I do the opposite over here and add 3 to that. So this is 10 to the 6th power. If you really want to see what you're doing here, kids, this is really what you're doing. Okay? What is 7863.2 times 10 to the 3rd really mean? It means 7863.2 times 10 to what is 10 to the 3rd power? 1,000. And when you multiply this times 1,000, you're moving the decimal 3 places right. So you end up with 7863, 1 place to the right, 2 places to the right, 3 places to the right. Now, if I'm changing this number into scientific notation again, it ends up being the decimal gets moved here, so it's 7.8632. How many places did I move the decimal? 1, 2, 3, 4, 5, 6. But rather than doing all of that work down there, you can just do it like this and move the exponent up there. That's really what you're doing, if you really want to know. One more, how about this one? 95.08 times 10 to the 8th power. In scientific notation, are you going to answer the question from way back there? Without even writing it down? It's not that hard. What did you come up with, Eli?
9.508 times 10
Times 10 to the what power?
9.
Right. You made this one smaller, so make that one bigger. Times 10 to the 9th power. Okay. Now, lest you think that you're done. I know, here's the grunt of, oh, you're kidding. We have to talk about division with scientific notation. So there's a lot going on here. And division looks like this. You have something like 2, 20. Let me get one out of the book so I don't give you something like this. 6.0. Sorry. 6.0 times 10 to the 8th power. Yeah, let's put an O there. 6.0 times 10 to the 8th power over 4.0 times 10 to the 8th power. Let's go with that. 4.8 times 10 to the 8th power. You could probably guess what the rules of division are because they're very close, except for the finishing part here. Step number 1 with division is you have to divide the left. And that's not going to be pretty, but we're going to do it. What is 6.0 divided by 4.8? Anybody? You get what? A 1 here? What do you get here? How many times does 480 go into 120? What's that? 2, which is 96. How many times is 420 going to 240? 5, take my word for it. So I get 0.125. Did I do something wrong?
Don't you have to move the decimal? Yeah.
Oh! Did I miss that? Is it 1.25? Yeah, sorry. Alright. You probably would have saved me 1,000. So I divide the left. Okay. I write down my times 10. Same thing, same thing. Now guess what happens here when I divide the right, which I need to do. How do I figure out what 10 over 8 over 10 over 8 is? And I know they're the same, so you might be able to guess what it is, but let me give you this little clue. If when you multiplied, you added their exponents, when you divide, you subtract their exponents. Okay? So when I take this is, I subtract the bottom. I take 8 minus 8, and this is times 10 to the 0 power. Now some people think that you don't need to write the 0 there, but you do, because 10 is not the same thing as 10 to the 0 power. 10 to the 0 power is 1. 10 by itself is 10. Okay. So this is, in scientific notation, it really just means 1.25, because 10 to the 0 power is 1, so that is kind of the answer. Let me give you one that's actually relatively easy here. What about this one? 22.4 times 10 to the 9th power over 8 times 10 to the 6th power. What do I get if I take 2.4 and divide it by 8? 0.3, is that right? Times 10. What do I get when I take 9 and subtract 6 from it? I get the 3rd power, correct? Is that my answer? No, because it's not in scientific notation. How do I fix it? Move the decimal one place right, it becomes 3. And since I moved it one place, I'm either going to add 1 or subtract 1. Jacob, I'm going to. I made it 1 bigger.
Oh,
Subtract 1, so it's going to be 10 squared. And again, there's a lot there to remember, and that's why you really should check your notes, or after you check your notes, if you don't quite get it, come talk to me, because I probably could clear up the murky waters of your disillusionment. Where does it say, one day is 80, express this number in scientific notation, how far light travels in a day? Where does it talk about how far light travels? No. Alright, what I would like for you to try and do is, how that works.